These slides explain how to do the observing circumpolar constellations activity. The purpose of this activity is to learn how to determine whether or not a constellation is circumpolar from a geographic location on Earth's surface. The central learning goal is to learn how to determine, for a given observation site on Earth, whether a constellation is circumpolar, meaning it is always above the horizon and visible, provided scattered sunlight doesn't outshine the stars, or if it rises and sets, being visible only seasonally at night, or if it is never visible because it is always below the horizon. The question answered is how to determine what regions of the celestial sphere are observable from a geographic location on Earth. This does not include factors that impact observability, such as the equipment limitations or obscuration by weather or buildings. After presenting some background information and the summary of formulas that were previously derived, you'll have the opportunity to determine constellation observability from your site. This activity builds on information covered in the module, The Earth Spins on its Axis. The following terms are used: latitude, celestial equator, north celestial pole, south celestial pole, and declination angle. To determine observability, the site latitude must be given. Lines of latitude are parallels running in an east-west direction that measure the distance north or south from the equator. The equator is a great circle and has latitude of 0 degrees. The equatorial region runs roughly -30 degrees to +30 degrees. The northernmost latitude, 90 degrees, is the North Pole, and it is a single point. Mid-latitudes in the Northern Hemisphere are from 30 to 60 degrees. Arctic regions above 60 degrees and below -60 degrees. Lines of declination on the celestial sphere are analogous to lines of latitude. To determine observability, the declination of a star must be given. Lines of declination are parallels running east-west directions that measure the distance north or south from the celestial equator. The celestial equator has a declination of 0 degrees. Stars with positive declinations are in the north celestial hemisphere. A declination of positive 90 degrees is the north celestial pole. Polaris is a star in the Little Dipper that is so close to the north celestial pole it can be used for navigation. Stars with negative declinations are in the southern celestial hemisphere. There is no star close to the south celestial pole. This is another view of the celestial pole showing the lines of latitude running from east to west. University of Nebraska's Rotating Sky Explorer shows stars on the celestial sphere and in the local horizon coordinate system. Here in Nashua, New Hampshire, we can see the Big Dipper is a circumpolar constellation. Orion rises and sets, and the Southern Cross is never rising for us. Stars, as observed from a particular site, can be classified as being circumpolar stars, meaning that they are always in the sky, rotate counterclockwise once per day around Polaris, or as rise-set stars, meaning they rise and set once each day and are seasonally in the night sky, and never rise stars. These are mutually exclusive characterizations of observability and depend upon the latitude of the observation site. In previous lectures, we derived relationships for circumpolar and never rise stars. If the sum of the declination and latitude is greater than 90 degrees in the northern hemisphere, the star is circumpolar. If it is less than -90 degrees in the southern hemisphere, it is circumpolar. If the difference between declination and latitude is less than -90 degrees in the northern hemisphere, the star never rises. If it is greater than 90 degrees in the southern hemisphere, it also never rises. Stars that are neither circumpolar stars nor never rise stars are rise-set stars. They are observable seasonally in the night sky. These classifications are site-specific and mutually exclusive. The University of Nebraska has a simulator that shows the declination regions of the celestial sphere are circumpolar, which are rise-set, and which are never rise for a given latitude. We see the regions divided into two declinations, plus and minus the absolute value of 90 degrees, minus the latitude for the northern hemisphere viewer, and plus or minus the sum of 90 degrees and the latitude for the southern hemisphere viewer. So you might think that the easiest way to determine constellation observability would be from a rectangular map of declination versus right ascension. Such a map is analogous to the equal rectangular map projection of Earth. If we wondered what countries were north of 45 degrees latitude, we'd just draw a line and see that part of USA, Canada, Greenland, most of Europe, Russia, and China are above that latitude. In 1922, Henry Norris Russell aided the International Astronomical Union in dividing the celestial sphere into 88 constellations. In 1930, the boundaries between the 88 constellations were devised by Eugene Delaporte. This equal rectangular plot of declination versus right ascension of the modern constellations has a dotted line denoting the ecliptic and a faint map from NASA of the Milky Way galaxy. Constellations are color-coded by family and year established. For an observer at latitude 45 degrees north on the Earth, the regions of declination above 45 degrees are circumpolar. Regions between 45 degrees and minus 45 degrees north rise and set and are seasonally in the night sky. And regions with declination below negative 45 degrees never rise and are not observable at any time from a latitude of 45 degrees north. However, these map projections are impractical for nightly viewing. For your lab, you should complete this activity and then make a journal entry. Your report should include the following: observation location, including unambiguous landmarks or street address or latitude and longitude. Observation date and local time, weather conditions, including cloud cover and precipitation. Observation description, describe what the sky looked like at the time and answer the following questions. Which constellations are circumpolar for your observation location? And which circumpolar constellations were you able to see?